Hey there, this is me, Mohammed Vamik, your computer science instructor. I hope that you have attended the last class and you are done with the activity. Just in case, if you have any queries, if you have any questions, please feel free to ask. I'm here to help. You can post it on MS Teams. You can just type me a message, or if there's any help you need, please don't hesitate to ask. I'm right here with you. In today's session, we are going to continue our lecture and we are going to discuss further that what are the next objectives of our lecture. So, I believe that we were discussing chapter data representation. So, just give me a moment. Okay, so this is the chapter that we were discussing in our last class. And let me notify you the lesson objectives that we have. So first of all, if it's okay, so the first area was that we need to show understanding of the binary magnitudes and the difference between the binary prefixes and the decimal prefixes. We have completed this into our last lecture in the first class. If you have any queries, please feel free to ask. I explained to you that you need to understand the difference between a kibibyte and a kilobyte, a megabyte and a megabyte, GB byte and a gigabyte, TB byte and a terabyte, making it show that we have two different areas for conversion, right? Like we have the decimal prefix, we have the binary prefix. The binary prefix is mostly like for the values of the computing, and we have discussed this that why do we need them, and whereas when it comes to decimal prefixes are those that we use into our everyday life. The conversion is right uploaded into MS Teams, so I hope that it's totally clear with you. Now, for the next area, we need to understand the basis of different number. We need to understand binary, we need to understand denary, we need to understand hexadecimal number, basis, and BCD number systems, ones complement and twos complement. So this is what we are going to discuss in today's class. So let's get along with it. Okay, so the first area says that I need to discuss with you that what is to be known as a number system, right? So if I am referring to a number system, first of all, you need to discuss and understand that in our everyday life, we basically use a language to represent numbers. For example, right now, when I was traveling from home to my school, I refilled my car with 4 or 5 reals of petrol. I went to the canteen and I purchased a water bottle that worth of 2 real. I went to the shopping and I spent around 50 reals for my clothing. Now you need to understand here the language that I'm using. It was 2, it was 50, or maybe something like in decimals, right? Like for example, I never saw that I went to shopping and I purchased clothes that worth 11000011. This doesn't make any sense because it is a different number system that is used by someone else. We have already discussed that the binary is used by the computers, and now when I am discussing in terms of everyday life, so it's a different number system. So that's the reason of having a number system, is that we have different areas where we can use that. So in our syllabus, I think that you have completed that into your IGCSE computer sciences, but I'm just giving you a recap that we have three types of number system. The first number system right here is to be known as binary. The second number system is to be known as either denary or to be known as your decimals. It has two names. You can even call it as a denary on the decimal numbers. And the third area I have right here is to be known as your hexadecimals, right? So these are basically three areas of the numbering system, right? This is the first area, this is the second area, and this is the third area. Now, I need to discuss with all of you that you all know that if I am referring to a binary value, that means only two options. That means only one or zero. That means only on, only off. So when I have only two set of values, that is only one and zero or zeros or one. That means that the number itself is binary. So the base of binary is considered as 2. Why is 2? Because it consists of only two numbers. The base is 2. And binary numbers are somewhere like, right, for example, 1 1 0 1 0 0 1 1 with a base 2. A binary is basically a machine friendly language, right? It is a machine friendly language, and I can say that it is only understandable by machines as well. Understandable by machines only, because or you can even say circuits, because binary is based on circuits. Computer is created out of integrated circuit because it is based upon two values. Only computer understand them, such as ones and zeros, on and off. So this is basically your first number system. A binary is not understood by humans. It is difficult for me to understand. It is a computer language, right? It is a computer language. So I hope the first one is clear. Now, the second area that we have to discuss right here is basically a decimal number system, a denary number system. And decimal and denary number systems consist of all values that consist from 0 till 9. That makes it 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are all of the uh, 10 values of decimal. And you need to understand one thing right here, that these are not 9 values, these are 10 values. The reason is that if I start counting them, they goes like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the base number of binary of decimal, the base number of decimal is 10. Why is that? Because it consists of 10 values. And why this number only stops at 9? You need to understand this, right? Like these numbers, all these numbers are unique in itself. That means that if I am going to take another number such as 10, 11, 12, they are going to be created out of combination of these numbers. For example, if I make 10, so I take 1 from here, I take 0 from here. If I take 11, I take 1 and 1 from here. If I take any number 40, I take 4 from here, I take 0 from here. So I only take 0 till 9 numbers because they are unique. Now, I use decimal numbers in my everyday life, and I can say that they are human understandable, right? Like they are understandable by humans. Humans can communicate into this language. The third area is to be known as hexadecimal. So hexadecimal is basically a base 16 number system. Why it is considered as a base 16 number system? Because it has values from 0 till 9. 0 till 9 means it has values from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then from 10 I have is A, from 11 I have is B, From 12 I have is C. From 13 I have is D. From 14 I have is E. And from 15 I have is F. So 0 till 15. If I count the all of them, it is going to make 16. And this is the reason I have hexadecimal number system as base 16. So if I go forward with this for the hexadecimal number systems, I can say that they are easier for humans to understand, and as well as I can also say that hexadecimals are basically compact representation of data. Compact representation, or you can say that it is basically a shorter or a portable representation of data. And this is the reason that it is mostly used by humans. Like for example, if you have an error into a computer system, right? Like for example, error E404, you are unable to connect to the website. Now, this error E404 is basically a combination of letters and numbers. And every time when you have a combination of letters and numbers, that means that you are using hexadecimal. So you often have seen the error of F4 somewhere else or something like any error. Have you ever thought that why not the errors are something like 111000011? Why it is not? Because we do not understand binary. It would be difficult for us to understand that. This is the reason that we always receive the errors with a combination of letters and numbers. So I hope that so far the basic concept is clear to all of you, that we have the number system binary, we have the number system denary, we have the number system hexadecimal. What is the main concept? What are the uses of binary? What are the uses of denary? What are the uses of hexadecimal? Right? Like for example, if it's a binary number, I can say that its example is that it is a machine-friendly number. And if it's a denary number, I can say that the examples of that are in everyday life of a human. If I'm referring to a hexadecimal number, a hexadecimal number basically means that it is a combination of letters and numbers, and it is used in humans' life as well. And some of the examples of hexadecimal are for example, you can name it like a MAC address, or you can say error codes. So we are going to discuss this all of these areas in detail. So your syllabus says that you should be able to have a knowledge of these three number systems. So I hope that I'm clear to all of you. The next area that we need to discuss is regarding their conversions. So I know that all of you are quite aware of these conversions, but only for the students, just to give them a recap of what we have already done into our last classes. I will be completing all of these conversions one by one. So the first conversion that we have right here is that if I want to convert from a binary number to a denary number, how I am going to do that? That basically means that, for example, if I have a binary number, for example, 1 1 1 0 0 1 base 2 to base 10. If I want to convert this number, how I am going to do that? So for conversion of a binary number into denary, I basically takes a series of numbers. And what are those series? The series is 1, 2, 4, 8, 16, 32, 64, 128. This is the series of the numbers that I take. And for the students who have questions into their mind that, sir, from where this series exists or where this series came, so you need to understand right here that I am converting from a binary to denary. A binary has base 2, a denary has base 10. That also means that I am converting from base 2 to base 10. So where this series come from? This is basically 2 is to power 0. this is 2 is to power 1, this is 2 is to power 2, this is 2 is to power 3, this is 2 is to power 4, this is 2 is to power 5, this is 2 is to power 6, and this is 2 is to power 7. So these are all the values that are from right here, and you need to understand that I am converting from binary to denary and the base is 2. So this is why I have taken this series. Now, what I need to do for the conversion is that simply I'm going to copy paste the number right here. So this is going to be a 1, 1, 1, 0, 0, 1, 0, 1. Now, as we discussed into our class that if it is 1, that means that we consider it as an on. And if it is 0, that means that I consider it as an off. So now what I'm going to do is that I'm only going to write those values that are considered as on. So for example, if it's this one says this is on, the value right here is 128. So I'm going to take 128. I'm going to take 64. I'm going to take 32, 128 plus 64 plus 32 and plus 4 and plus 1. I took all of those values that are uh, on, that are 1. And now what I need to do is that I need to add all of these values. So if I add them together, 124 plus 64 plus 32 plus 4 plus 1 is basically 229. So the final answer is 229 with base 10. And you need to remember here one thing, that no calculators are allowed. You need to do it on your own. So that's the first conversion. I hope that it's clear. With the same method, you can complete any other conversion. Now, if I'm going to discuss with you the second conversion that we have is basically if I want to convert from a denary number into a binary number, and the process is same. So, for example, if I have a denary number that is 65 and I wish to convert it into a binary number, since this is a denary number, that means it is a number that is of my everyday life, right? And if it's a denary, that means that it's base 10. And I'm now converting it into binary. So that means that it's base 2. So now for converting it, what I'm going to do is again, I'm going to write the same series of number, which is 1, 2, 4, 8, 16, 32, 64, 128. And now what I am going to do is that I am only going to add 1 only on those values that makes it a total of 65. So for example, should I take the value of 128? Should I take it? Should I write it here? No, I will not, because this is the value that is greater than that. So I'm going to write here 0. Now, should I take 64? Yes, I will take it, because this is the value less than my question. So I should be taking 64. And now I need one more to make a total equivalent of 65. So 32, I'm not going to take it. 16, I'm not going to take it. 8, I'm not going to take it. I'm also not going to take 4. I'm also not going to take 2. Only going to take 1. So this is going to be considered as 1. So these are the values that I am going to consider. These are the values that are settled as on. So if I add them together, this basically makes 64 plus 1, 65. And at the same time, the number that came right here is basically to be known as your conversion from denary to binary. So 0, 1, 0, 0 and 0, 0, 0, 1. So this is basically your binary number, your second conversion. So I hope it's clear. So basically, when you are converting from a binary number to denary, what you do is that your series is same. You just simply copy paste the number. You just check that which values turned as on, and those values that are turned as on, you add them together and you have your final answer. But now similarly, if you are discussing with a denary number, you need to write down the series and you need to find out that on which numbers you add 1 to make a total of that number. So I hope that the two conversions are clear to you. Just in case if you have any queries, please feel free to ask. Now, for the third conversion. Now, let's say if I need to convert from a hexadecimal number to a binary number. So what I need to do, right? Like for example, if I have a hexadecimal number, you need to remember right here one thing is that now when I'm referring to a hexadecimal number, that means that that is basically a combination of letters and numbers. So for example, if I have a hexadecimal number such as C5 base 16, and I want to convert that into base 2. So what I'm going to do right here is now I am going to write the solution. So what I'm going to do is that I'm going to split this into two sections. The question, right? Like first I'm going to write C here, I'm going to write 5 here. And now what I am going to do is I'm going to add the numbers here. What are going to be the numbers? The numbers are going to be 1, 2, 4, 8. The numbers are going to be 1, 2, 4, 8. And why I am writing these numbers? Because if I add them together, that makes a total value of 15. They makes a total value of 15, and numbers from 0 till 15 makes it base 16, and that's how I'm referring to that. I'm converting from hexadecimal to binary. So I need to make C here, and in hexadecimal you know it already that I have numbers from 0 till 9. 10 is considered as A, 11 is considered as B, 12 is considered as C, 13 is considered as D, 14 is considered as E, and 15 is considered as F. So I need to have the 12 here. So now I'm going to put 1 only on those values. I'm going to set 1 on only on those values that makes the total sum of 12. So should I take 8? I will be starting from left hand side. Yes, I will be taking it. Should I be taking 4? Yes, I will be taking it. So 8 plus 4, 8, 9, 10, 11, 12. That makes the total value 12. The C is of 12th value. The C is of 12th value. So 8, 9, 10, 11, 12. That's it. I do not need these values. Similarly, I need to make 5 here. Should I take 8? No. Should I take 4 here? Yes. Should I take 2 here? No. Should I take 1 here? Yes, because 4 plus 1 makes it 5. So this is my final answer for conversion from hexadecimal to binary. I hope it is clear to all of you. I'm repeating it back again. You need to split your question into two sections. You need to write down the series and then you need to number them to make them equivalent of what is given into your question. For the fourth conversion I have is if I want to convert a binary number into a hexadecimal number. That means that, for example, if I am converting from base 2 to base 16, so what I need to do right here is that for example, if I have a binary number such as 1 1 0 0 0 0 1 1, this is a binary number and I want to convert this into a hexadecimal. So what I'm going to do is I'm going to first of all break this into two sets of 4 each. Now it's going to be something like 1 1 0 0 0 0 1 1. So I have broken them down into two sets of 4 each. Now what I'm going to do is I'm going to write the series here. The series is going to be again 1 2 4 8 1 2 4 8 1 2 4 8. This is the series. Now I'm going to add only those numbers that is considered as 1, right? Because 1 means on. So I should be adding 8 and 4 here. So this is going to be 12, 8, 9, 10, 11, 12. And right here 2 and 1. This makes it 3. 2 plus 1 makes it 3. So the answer is C, 3, right? Because 12 is considered as C into hexadecimals. So this is how you can convert a binary into hexadecimal and hexadecimal into binary. Other than that, I have another conversion, that is how can you basically convert a denary number into a hexadecimal. So this is also easy. So for example, there are basically multiple ways for solving that, but I just go through with the most simplest and the easiest method. So for example, if you have a number such as 65 of denary and you wish to convert it into a hexadecimal number. So what you are going to do is you are going to solve this with two steps. Your step one is that you are going to convert denary into binary, and then for your step two, what you are going to do is that you are going to convert that binary into hexadecimal. So first of all, let's convert this. This is my step one. I'm going to convert 65 into binary. I can do that by 1, 2, 4, 8, 16, 32, 64, 128. I'm going to take this denary into binary. So this is going to be like, for example, 0, 1, 0, 0, 0, 0, 0, 1. So the final answer of this is 0, 1, 0, 0, 0, 0, 0, 1. So this is the binary answer. And now I believe that we have already completed that. What we need to do that if I'm converting from a binary number to hexadecimal. So now what I'm going to do is that I'm again going to break this into a series of 4 to each, and now I'm going to add 1 2 4 8, 1 2 4 8, and I'm going to add 1 2 4 8. So the answer for this is going to be 4, and the answer is going to be right here 1, because 1 is placed only on those values. I'm going to consider them only. So the answer for this is going to be 41 base 16, or you can say 41. So this is your conversion from denary to hexadecimal. I hope it's clear. It's based upon the two stages. First, you need to convert the denary into binary. Then you need to convert the binary into hexadecimal. Now, for the sixth part, the sixth conversion, the last conversion is that if you want to convert a hexadecimal into denary. So, for example, if you have a hexadecimal and you wish to convert this hexadecimal into denary. So how you are going to do that? So for example, if you have a question such as f6 of base 16 and you need to convert this into base 10. So perhaps what you need to do right here is that you need to solve this question by breaking it into two areas. The first area is going to be where you are going to convert the hexadecimal into binary, and for the second part, then what you are going to do is that you are going to take this binary into denary, and we have completed that. So there are multiple methods for solving that, so it's totally up to you. I just care for the answer. If your answer is correct, then you are good to go. So for converting this, I'm again going to break it into two stages, and now I am going to write my initials, and those are 1248, 1248. Now you know it. If it's a hexadecimal, I have numbers from 0 till 9. Then I have 10 is A, 11 is B, 12 is C, 13 is D, 14 is E, and 15 is F. So for making a 15F, I'm going to add all of these values. So 8, 9, 10, 11, 12, 13, 14, 15. And for making 16, I'm not going to take this 8. I'm going to make it 0. Should I take this 4? Yes. And 4, 5, 6. I'm not going to take this. So the answer is 1, 1, 1, 1, 0, 1, 1, 0. Now this is the binary I have received. Now what I'm going to do in my step number 2, I'm going to convert this into a denary. So 1, 2, 4, 8, 16, 32, 64, 128, and now what I'm going to do is that I am going to uh, convert this right here. So this is going to be 1, 1, 1, 1, 0, 1, 1, 0. So the answer is going to be, I'm going to add these values. This is 128 plus 64 plus 32 plus 16 plus 4 plus 2. So I'm only going to take the values that are considered as 1. And if I add them together, you need to understand that you don't have any calculator. So for example, If it's 128 plus 64, I think it's around 192. So 192 plus 32 plus 16 plus 4 plus 2, it's 246. The answer is 246 in Denary. So this is it for your conversions. In this class, I have explained to you that what is basically a number system and what are the conversions. Following this lecture, I will be providing you with an activity. You all have to complete that and you all need to share it with me. Please don't hesitate to ask. If you have any questions, please feel free to ask. I'm here to help. I'm here to facilitate. Just in case if you have any problems or if you feel like if there's any major difficulty, please don't worry at all. When I'll be when I'll be there, I'll be revisiting these areas. So don't worry at all. You can post your questions, you can post your queries. I'm submitting an activity along with that, so you can definitely go for it. Thank you so much.